Hi, I'm Uzai, and today I'm going to be showing you how to use Druids, our agent library, to optimize the implementation of Python. So here is the Druids interface. Druids is a way of describing agent processes that manage various agents and machines and coordinates them to accomplish a task. So this is the execution of a Druids program. So these agents are all working together to optimize the CPython implementation of Python and make it faster. So to define this program, I define various agents with different roles. So my main agent, basically, its role is to manage these workers. And each worker is working on different ideas, different optimization ideas in parallel. And then these ideas are going to be benchmarked, and the work that's done is going to be benchmarked. And the main agent will decide what to merge back in. So each node is a different agent, operating on a different machine in the Druids cloud. And the edges between each agent basically define how they can communicate and whether they can communicate. The main agent can send and receive files and messages from all of the workers individually. So this is kind of the high-level structure of our optimization program. Now let's look at what it actually takes to deploy this and what it means to define such a program. If I go here, I can look at the actual code that we deployed. So this is our optimization program. There's this local function that basically got deployed to the Druids platform. It has this context object, which is the Druids context, allows the program to call the Druids methods. So here we define the agent, the main agent. And each of these agents is going to run its own copy of some snapshot with CPython and the CPython dependencies installed. And what we're going to do is we're going to give these agents events that they can call. And these events are how we control the way agents can modify the state of the program and sort of advance the process towards completing the task. So for example, the main agent is able to call a spawn worker event as a tool. And that spawn worker event is going to create a new agent working on some idea that's hooked up to the main agent. So here you can see it's going to call a spawn worker function. Now we can go to this function and we can see that it creates an agent, same as the main one. And it connects this one to the main agent, and it gives it this eval tool. And what this eval tool does, or this eval event, is it runs a benchmark to check how fast the optimizations of the agents were. And it sends a message back to the main agent to notify it of the work and decide if it wants to merge it in. So that's our simple optimization program. Let's see what it takes to actually run this again. So basically, I just exec the program, and I define the dev box, so dev sandbox environment in which it runs, which is a CPython environment with everything set up. So I can create this program. Now we're back at the interface, and I'm just going to connect and provision, and we should see the agents stream in over here. So the agents are appearing and getting arranged into their hierarchy. And as we saw earlier, you can talk to all of them, you can see what they're doing, and yeah, they're going to start cooking away. And let's see what optimizations they come up with. The main agent will come up with some more ideas and spawn many more agents to accomplish the task. Cool. So I asked the agents to make a web page documenting which optimizations got merged in the process. So here we can see the various optimizations. Here we have the actual work that the agent did and what kind of optimization angle it took. We have the speedup, and then we have the files that are modified. The speedups are on sort of various subsets of the benchmark. So yeah, I'm excited to show you our Druids system, and you can try it either on druids.dev for the platform, or there's an open source version that you can run locally. Thanks for listening.